Hello everyone, welcome back to my channel. Today we're tackling the find subarray with given some problem. In this video we'll also be covering a very popular technique that can help you in bringing down your time complexity from the order of n squared to the order of n. The technique in itself is very easy, however, it can even solve the hard level leet code problems. So without wasting any more time, let's start with the problem description. Given an unsorted array A of size n that contains only non-negative integers, find a continuous subarray which adds to a given number s. In case of multiple subarrays, return the subarray which comes first on moving from left to right. We also have an example, so let's draw it up. We have an array of size 5. The elements are 1, 2, 3, and 7, and 5. Okay. By the way, this problem, it has many variants, but the one that we are solving right now, it is like the base variant. It is the most easiest one. Why? Because they have already said that this is going to have only non-negative integers. Also, we only have to return the first subarray, right? This problem would have been a bit more difficult if they have even provided us, if they had also assorted the negative integers, but that is not what we are going for right now. Our main priority here is to learn how to tackle these sort of problems. Okay, so let's try to understand this. They are asking us to return a subarray that has a given summation of 12. So basically, what is a subarray? This complete array has various subarrays. 1 is a subarray, 2 is a subarray, 1 to 3 is a subarray, 3 7 is a subarray, right? So we need to find a subarray whose sum is equal to 12. So we do have a subarray here that is 2 3 7. This is subarray and its summation is equal to 12, right? So this is one of a subarray. Do we have any other subarray? Yes, we have 5 7. We are supposed to return their positions. So the indices are definitely 0, 1, 2, 3, and 4. But the position right there, they are starting from 1. So the position are like 1, 2, 3, 4, and 5. So 3, 4, and 5. So the answer here will, there can be two answers, right? 2 and 4 or 4 and 5. But since they have already, reduced the issue for us, they have already said that you have to return the one that you encountered the first when going from left to right. So answer here will be 2, 4. Now let's talk about the approaches. The first approach that will be coming to our mind is maybe we can formulate all the possible subarrays and we will move from left to right, and whichever first subarray we encounter that has the summation of 12, that is going to be our answer, right? But what will be the time complexity of this problem? Since we will be traversing the array first time and then we'll traverse it again to form all the possible combinations, the complexity is going to be the order of n square. It will definitely be able to solve your problem, but will it be able to pass all the test cases? Looking at the constraints, I don't think so. So we need to come up with a different approach. So now it's time to talk about the sliding window technique. What the sliding window technique says, it says that how about you create a window of size 1 and then you add or delete element on it on the basis of some condition. This is basically what sliding window technique is. How exactly are we going to use it in this problem? Okay, simple. Let's try to say, okay, this is my window. This is my sliding window. Okay, my logic here is going to be, if the summation of all the elements inside the window is smaller than the sum provided to us, then I'll add element. If the summation of all the elements inside the window is equal to the sum provided to us, that is our answer. If the summation of all the elements inside the window is greater than sum provided to us, I will remove the element. Okay, so now let's move it. Now let's actually try to implement this. So this is a window. The sum is 1, the total is 12. This is smaller, right? So I will increase the size. Now my window is 1 and 2. Okay, 1 to summation is 3, again smaller than 12. Now I'll again increase my window, 1, 2, and 3. Cool. Summation inside the window is 6 and the provided to us is 12, again smaller. So we have 1, 2, 3, and 7. What is the summation now? It is 13 and 13 is greater than 12. So in this case, we need to delete an element. And which element are we going to delete? We will delete the first element, since we need to find a contiguous subarray, right? So the window now is going to be 2, 3, 7. Let me change the color so we can look at it a bit better. So 2, 3, 7 is going to be a new window. What is the summation? It is 12, and yeah, the sum that was provided to us was also 12. So this is our answer, 237. We will return its position 2 and 4, and voila, we're done. How about we take another example? We will take 3, 2, 4 and 1, and we have to find s equals to, let's say, how about 7, right? 7, cool. So let's start with a window. The first, this is going to be a window, right? 3 is smaller than 7, okay, add an element. 3 to 5, 5 is smaller than 7, okay, push another element. 3 to 4, now it is equal to 9, but 9 is greater than 7, so we will delete an element. Now our window is 2, 4, 6, it is smaller than the total sum provided to us, so we'll add another element, 7. So we will return the position of 2, 4, 1, that is going to be 1 comma 3, and this is our answer, right? So now let's try to think about the time complexity of this logic. So in any given question, you will only add an element once, right? So the adding will cost you an order of n, and you will only, in the worst case, right, you can only delete the element once. So again, you'll get on plus on. It gives you a complexity of 2 on that comes up to order of n. So we have brought down a complexity from order of n squared to order of n. Let's revisit the logic. It's very simple. We'll start if the total summation of elements inside the window is smaller than the sum provided to us, we'll add an element. If it is equal to the sum, we'll say that this is the answer. Because we are moving from left to right, the first window we encounter, that is going to be our answer. If the total summation of elements inside the window is greater than the sum provided to us, then we'll remove the element. Okay. Now we'll also talk about the space complexity, right? This seems to what kind of data structure do we need? Do we need a queue? Because this sort of represents queue. You are adding an element, you are deleting an element, but now we don't need a queue. We only need two elements. We need two variables, my bad. So one will be called, let's say, starting point, and one will be called ending point. These two using these two, we can formulate a window. The s will be used to track of the starting endpoint of window. The end will be used to track the ending endpoint of window. How about that? What about the time complexity? Again, it's going to be 2 order of 1 coming out to be order of 1. So we will be able to solve this problem with a time complexity of order of n, space complexity of order of 1. How that? This is the approach with which we'll be solving this problem. We'll move to the coding part. And by the way, if you have any solution that can, reduce the complexity of this problem, maybe to O log n, O root n, or something else, please do share with me that. I'll love to learn it. Right. Now let's move to the coding part. Okay, we will be attempting this problem using C++. Don't get intimidated by this vector sign here. Vector is sort of similar to array. However, it has one major advantage, that you can add or delete element on the go. Its size is dynamic, unlike array, which has a static size. I believe I have covered a vector in the series known as Things Every C++ Programmers Must Know. So you can go check it out. I'll share it. And if you want to know anything else, do tell me in the comment section. Alright, let's start. So I will create some variables. Let's call it current sum, right? That will be storing the summation of our window. Okay, and I only need two variables to manage my window. Let's call it start and end. Okay, what else do we need? We need a vector that will be returning, so let's call it as result. Cool. Now let's start a logic. While was going to be a condition, when the starting point of the window reaches to the last element of array, that is when this loop should close, which means we have no more element to traverse over, right? So when till the time start is less than n, we'll check a logic for window and add or delete element accordingly. So what was our logic? Let's check it again. If current sum is equal to s that they have given us, this is going to be our answer, right? This is their answer. Since we are starting from left to right, the first condition where current sum is equal to sum, those two positions we needed. What are going to be the position? It's going to be start plus 1. Why? Because we need to return the position, not the indices. And result dot push, I think it was pushback, probably. This is pushback and push. Pushback is a function of vectors. you can see we do not have any allocated size of vector called a result, right? But using pushback, you can append element to it, onto it, and then you can return it. This is sort of our happy case, right? We have returned it. Now let's come to the main logic. If there's only two cases left, right? If sum is greater than current sum, or if sum is less than current sum. So if sum is greater than current sum, what will we do? We need to increase the size of current sum, but by how much value? By the value at which your end is pointing. A of end, and you need to ask your end to move one position forward. Done. Otherwise there's only one condition left, right? What exactly is that condition? Current sum is greater than sum. When current sum is greater than sum, what exactly are we supposed to do? We are supposed to decrease the size of current sum by the value at which your start is pointing, and you'll ask your start to move a bit forward. Cool. Yeah, that is done. By the way, I'm not really sure what are we supposed to return when we don't. Okay, return an array consisting only one element, that is -1, if you are not able to find. Great. So in that case, if if I've traversed the complete array and have not returned any value, it will only imply that there are no such subarray which has a sum equal to s. So in that case, we'll return a vector of size -1. Cool. Now let's try to run this. We have a compilation error. Okay, it says that some. Okay, my bad. So okay, I'll say this is s, and I'll make this as sum. Oh my bad again. This is ARR. I don't think I actually remember the name of the arguments provided to me. Your output is -1, 2. Okay, I am providing a wrong output. Let us see why. Oh shit. I returned inside the loop only. My bad. This is completed 2424. Now let's try to submit this. Successfully, all of the test cases have passed. We have taken a time of 0.43 seconds. So this is how we solve summary with given sim problem. If you have any question, feel free to ask them in the comment section, and I'll see you in the next video with some other interesting problem regarding arrays, because this is our must do series where we are tackling all the array problems. Thank you for watching.